Hello everyone, this is Mohammed Imran sir. In today's lecture, I'm going to talk about three-phase systems. So let us begin with our discussion of three-phase systems as Unit 2. To start with the topic, let us talk about voltages and currents in three-phase system. Voltages are of two types, basically line voltage and phase voltage. Similarly, the currents are also of two types, line currents and phase currents. The topic of discussion is star and delta connection, which are the two different types of connections for three-phase system. To begin with, let us say that we discuss first about star connected three-phase system or simply star connection. So when we say three-phase, there are basically three lines. Let us say that those three lines or three phases are represented by individual lines. The first one as the red one, second one as the yellow one, and the third one as the blue one. And since it is a star, all of these will be shorted with a line forming a common connection called as neutral. This black color line is called as neutral, which forms a common point for these three lines. Now each line will have its individual current. Let us say the red line has its own current as red current. The yellow line has its current as yellow. Similarly, the blue line has the current as blue, IB. Then the current flowing through the neutral is simply denoted by letter IN. Since it is neutral, the charge to this line will be 0, or the current flowing through the neutral line will be 0. In other words, let us say this is one potential and this is another potential. This is red potential point, this is yellow potential point. So the voltage between those 2 points will be called as V red yellow voltage, red yellow. Similarly, we have got yellow blue, then the last one is blue red. So the cycle gets complete. It starts with red, yellow, then yellow to blue, then from blue to red. So it starts from red and ends at red. Then let us talk about the other voltages which are between this red point and the neutral point. This is the neutral line. So that voltage will be called as VRN. Similarly, VYN and VBN. So these voltages, the potential difference between one point R and neutral point N, are called as phase voltages, whereas the other voltages VRY, VBR and VYB, they are called as line voltages. Now let us move on to the next one. Let us say we have got node here. At that node we apply KCL, because all the currents are going inside a node and neutral current is coming out. Since this current is 0, algebraic sum of currents going in is equal to current coming out. That is equal to 0. This is the equation we get. Then let us draw the phasor diagram for three-phase star connected system. Let us say we have got VR, VY, and this is VB. All these three are 120 degrees in angle with respect to each other. Why? Because there are three lines and they have a complete 360 degree rotation. So 360 degrees divided by 1, 2, 3, each will have 120 degrees apart. They have an angle 120 degrees difference between them. So as a result, now let us say that our first vector, what we have to get is VRY. So in order to get VRY, let us project Vy in the negative direction. So it becomes minus Vy, because VRY in vectors is like VR minus Vy. So we need negative Vy in that case. So we are projecting Vy in opposite direction. Now let us draw one line parallel to this, okay, and one line parallel to that in this way. So it forms a parallelogram, and the resultant represents the vector sum of these two, VR minus Vy, vectorially written as VRY. So basically we said that VRY are the line voltages So I come to a conclusion that the resultant of the parallelogram represent the line values. Okay, so now how much is this angle? Is nothing but it's 30. How can we say it's 30? Because between red and yellow 120. Similarly, between this red and this blue, B for blue, is 120. Between these two is 120. So here 120 is cut into half and half. So this is 60 and remaining is 60. But this remaining 60 is again cut into half and half, that is 30 and 30. So this makes 30. Now similarly I am drawing for other voltages, the vector diagram you can see with the 30 degrees angle. So I'm just drawing, I'm completing the complete phasor diagram for all the three phases. That's why it is called as a three-phase system. You can see that. So now let us try to draw a perpendicular from this path to that part so that it makes a 90 degrees. In all of them it makes a 90 degrees. Then let us denote them O, B, C, triangle O, B, C. Let us denote that. In that triangle, if I take a scissor and cut out this triangle, let me apply cos theta, which is equals to half of this complete line, which is VRY divided by 2 whole divided by VR, which is OB. So indirectly I am saying is OC divided by OB. OC is nothing but half of this line, complete line, VRY by 2 by OB is nothing but VR. Cos 30 is root 3 by 2. This is VRY by 2 into VR. So 2 gets cancelled. By cross multiplication I end up with VR is equal to VRY divided by root 3. So VR is like VRN or simply termed as VR. So VR is called as phase voltages is equal to line voltage by root 3. So we come to a conclusion that when three wires are connected in star in three-phase system, the phase voltage is exactly equal to line voltage divided by root 3. What about currents? They remain same. What about currents? They remain same. Line current is exactly equal to phase current. Now let us talk about delta connected three-phase system. In this delta connected three-phase system, all the three wires are connected in the form of delta. So let us try to pull one line from this point, common points. This is red, this is yellow, and finally this is blue. So red has is red current, yellow has yellow, and blue has blue current. And the currents which this is delta. It looks like closed path or a delta shape. That's why the connection is called as delta connection. So they also have some currents flowing in them. Let us say that the direction of current is taken anti-clockwise. The first current is between R line and it is going to yellow. That's why it is denoted as IRY. Similarly, IYB, BR. So it follows the sequence and close the loop. So now we have three nodes, node A, node B, and node C. Let us apply Kirchhoff's current law at these three nodes ABC. We end up getting IR is equal to IRY minus IBR, IY at node 2, IY is equal to IYB minus IRY at node 3, IB is equal to IBR minus IYB. Now let us try to draw the phasor diagram of delta connection. We will take three currents IRY, IYB, and IBR 120 degrees apart with respect to each other. So what equation we have got for delta? Let us say IR is a resultant in the phasor diagram. It should have positive IRY, negative IBR. So in order to get IR, I should have negative IBR. Similarly for IY, negative IRY. For IB, negative IYB. That's why the vectors are taken IRY, YB, BR on the positive side with 120 degrees apart in angle. So now let us say that we take negative of IBR, draw parallel line to that here. Let us say this line is parallel to this. The resultant indicates IRY minus IBR, which is IR, and this angle we know already it is 30, similar to star connection. So similarly we will complete all the three equations. For all the three equations for delta, we draw all the three parallelograms and we get the resultants. After that, we try to mark a perpendicular from this point to this, so that we can cut out a right angle triangle in this to apply cos theta. So OBC again, if I apply cos theta, cos 30, that means to this triangle I take a scissor and I cut out this right angle triangle with cos 30. So I'll get cos 30 is equal to half of this, because it is complete line is IR, so I need only OB, which is half of IR. So IR by 2 divided by this line. This line is IRY, so that is nothing but multiplied by IRY. IR divided by 2 by IRY is equal to IR divided by 2 into IRY. So cos 30 is root 3 by 2. This is equal to IR by 2 into IRY. 2 gets cancelled. IRY is equal to IR by root 3. Now that means I come to a conclusion where phase currents are exactly equal to line current by root 3. So in delta, currents get altered, whereas previously when we have connected the system in star, voltages got altered. So now here in this case in delta, voltages remain same. So these are the two important connections in three-phase system that one has to know and draw their respective phasor diagrams. Thank you for watching my video lecture. See you in the next lecture.